prime factorization. Prime factorization. This is got a couple different names, aka also known as, sometimes it's called product of primes. Sometimes we call it the tree thing. But basically what it is, and they had it, I saw problem number 18 or something today. Was it 18? No, problem 25. Okay, talked about what you are doing with prime factorization is you are taking a number and you're breaking it down so that it is the result of all prime numbers multiplied together. So 20 would be this, 2 times 5 times 10. If I multiply these three together, I get 20. Sorry, let's change that to what it would be. 2 times 2 times 5. If I multiply these three numbers together, I get 20. And these have to be prime numbers. I can't put a 4 there because it's not prime. 2 is prime, no other number goes into it. 2 is prime, 5 is prime. Now, obviously, you're not supposed to be able to just, the goal is not to do this in your head. We have two different ways that you can do this, and that's where the tree thing comes in. Here is, one way to do it is to make a factor tree. And I call it a factor tree because when you do it, it looks like a tree. If you take 20, you split it down into two factors. And you say to yourself, well, what times what gives me 20? Well, 4 times 5 is what most people say. Okay. You look at those two numbers. Are either of those prime? Yeah, 5 is a prime number. You can't split 5 down. You can always put 1 times something, but that doesn't do you any good. So you stop. I would circle that 5. You can stop with that one. But 4 can be broken down into what number times what number? 2 times 2. These are both prime, so you can stop there. And then when you rewrite your answer, you need to write it as 20 equals 2 times 2 times 5. This is a factor tree because it looks like a tree as you factor it out. Okay. Another way, actually I probably should have also put that up here, aka, another way to do it is by division of primes. And that would be this. And it says, just like it says, it's doing a dividing problem. You can factor this out by making this, you always want to divide by a prime number. So what's a prime number that goes into 20? If you can, always try 2's because cutting numbers is in half. So I start with the 2. Half of 20 is 10. Okay. Now I do 10. What number goes into 10? Well, I can cut 10 in half again, divide it by 2, and I get 5. 5 is a prime number, so I can stop. So I've got my prime numbers right here that when I remultiply would give me 20. So that would be 2 times 2 times 5. We'll do a couple more so you can kind of see this. Let's say I was doing 36. Okay, again, if it's even and you're doing division by primes, I would always do 2. Okay, 2 goes into 36 how many times? 18. Please know you cannot say 9. You can't divide 18 by 9 because 9 is not a prime number. You always must divide by something that's a prime number. You know, just for fun, I could say, well, I know 3 is a prime number, so let's divide 18 by 3. I divide 18 by 3 and I get 6. I can't stop because 6 is not a prime number. What goes into 6? Well, you could go 2 again, cut it in half, you get 3. Once you get to the top, you can stop. That 3 is prime, so you can stop there. And those are the numbers that give you 36. 2 2's times 2 3's. Or doing it as a factor tree would look like this. And it doesn't matter how you start. There's multiple ways you could divide 36. You could say 4 times 9, 12 times 3, 18 times 2. Either of those, any of those will work. I'll use 9 times 4. Can I break down either of those? Sure. What times 1 gives me 9? 3 times 3. Those are both prime numbers, so I can stop because I can't break them down anymore. Like I said, it doesn't do you any good to do this. 3 times 1 would just be goofy because all you keep doing is you can keep doing 3 times 1 forever. So, and what does 4 break down into? 2 times 2, and both of those are prime. So you end up with 2 times 2 times 3 times 3. Let me give you one. How about 100? Do 100 as a factor tree. Do 100 as a factor tree. What do you get for the product of primes with 100 if you do it as a factor tree? A factor tree. Brant, what'd you cut it into first?
50 by 50.
What? 50 times 50 is 2,500. Okay. Huh?
I thought you were supposed
It's what?
to do something else.
What times what gives you 100? That would be the question you ask you. Now 50 times 2 would work. Let's start with that. 50 times 2. Stop with 2 because it's a prime number, but 50 can be broken down into 25 times 2. Again, you can stop with 2 because it's prime, and then 25 can be broken down into 5 times 5, both of which are prime numbers. So 100 equals 2 times 2 times 5 times 5. Now, how about this? What about 1,000? And I want you to do it as division problem. Division by primes. Division by primes. Do 1,000, only divide it by prime numbers. $1,000 as division by primes. You have to divide it by a prime number. You can't use 10 or 50 to divide it by. It has to be a prime number, i.e. 2 or 5, 7. You know our rules of divisibility. What did we end up with? Faith?
2 times 2 times 2 times 5 times 5.
Yeah, let's see. I would again, if it's an even number, I would always use 2 because it's pretty easy usually to cut numbers in half. Half of 1,000 is 500. Another even number, so again, I would cut it in half. Half of 500 is 250. Oh look, another even number. Half of 250 is 125. Oh, not an even number, but it ends in a 5, so I know 5 goes into it. 5 goes into 125 25 times, and again 5 would go into 25 5 times. So you end up with all these 5s and all those 2s. 2 times 2 times 5 times 5 times 5.